Hello there, Nareg is here, and today I'm gonna talk about the nth root of a real number. Previously, I did a video about the square root of a real number. In this case, we're gonna talk about the nth root of a real number. What do we mean by nth root? Let's first consider that we have two real numbers, a and capital A. Whenever I'm going to write down a to the power of m is equal to capital A, and of course m should be a value belonging to the natural numbers, when I try to find the value of small a, it will be the mth root of a, and this is how you find the nth root of a certain value of a certain real number. Now in this case we have to discuss about m. So we have the mth root of a, which is in this case capital A. What happens if m is odd? If m is odd, you can simply say that this mth root of a will give you one unique solution or one unique root. Now if m is even, now in this case you have to discuss if a, capital A, was negative, it means a does not exist. A does not exist. Now if a is positive, you have two real roots. Now in this case a will be equal to the plus the mth root of a or the negative mth root of a. Let's take a few examples in order to understand this part. So let's say we have the first one, it was when m is odd. So the cubic root of 8, it means that it's the cubic root of 2 to the power of 3, which is 2. The cubic root of minus 8 is equal to the cubic root of minus 2 to the power of 3, which is minus 2. As you can see, you're having one real root, a unique root. What about, let's say, the fifth, or in this case I'm going to take again the cubic root of minus 125. It's the cubic root of minus 5 to the power of 3. The answer is minus 5 is one unique root. Now what about the part where it is even? So this was for m, so I can simply remind you that this was for m odd. Alright, when m is odd. Now the second part is when we have, let's say, the fourth root of 16. As you can see, 16 is positive. So the fourth root will exist and it will give me two answers. It will be plus 2 or minus 2. In case I had the fourth root of minus 16, in this case minus 16 is negative, so I will have no roots, or it does not exist. So I can say it does not exist. Okay, what about the square root of 25? You know that it's plus 5 or minus 5. Alright? What about the square root of 0? It's 0. So in this case, we're taking when m is even. I have two choices. When the number that I have below the root is positive, you will have two real roots. And in case it was negative, you will have no real roots, or you can simply say it does not exist. So let's go and talk about the properties related to the nth root of a certain real number. So when we have, let's say, the nth root of a and the nth root of b, even the nth root of c, whenever they exist, the first property that I can talk about is the nth root of a times the nth root of b is equal to the nth root of a times b. Similarly, the nth root of a times the nth root of b times the nth root of c is equal to the nth root of a times b times c. Let's take an example related to this property. So what about the fourth root of 2 times the fourth root of 4 times the fourth root of 32? It will be the fourth root of 2 times 4 times 32. It is equal to the fourth root of 256, which is 4. All right. The second property, when we have the nth root of a over b, it can be written as the nth root of a over the nth root of b. So let's take an example. The cubic root of 189 over the cubic root of 7 is equal to the cubic root of 189 over 7, which is the cubic root of 27, and it's 3. Similarly, I'm going to take another example. What about the fourth root of 48 over the fourth root of 3? It's equal to the fourth root of 16 times 3 over the fourth root of 3, which is equal to the fourth root of 16 times the fourth root of 3 over the fourth root of 3. Excuse me. Over the fourth root of 3. So they can cancel, we can cancel out this part. It will be the fourth root of 16, which is 2. All right. Now, what about the case where we have the power a rational number? So, power with rational exponents. Now, about this part, I had previously mentioned in a video related to the power of real numbers. So this is directly linked to it. Power with rational exponents. The first property is that whenever you have a to the power of 1 over n, you can simply write it down as the nth root of a. Of course, you have to discuss about a and n whenever it's even or odd, and a should be positive, negative, etc. Or you can say a to the power of m over n. It can be written as the nth root of a to the power of m. So let's take some examples related to this case. What about 64 to the power of 2 over 3 times 64 to the power of 1 over 2. So we can write it down as the cubic root of 64 to the power of 2 times the square root of 64. So it's equal to 4 to the power of 2 times 8, which is equal to 128. What about, let's say, 2 to the power of 1 over 2? You can simply say it's the square root of 2, which is radical 2. Similarly, when we have 2 to the power of 1 over 3, it can be written as the cubic root of 2 to the power of 1, of course, which is the cubic root of 2. Alright? The last part, I'm going to talk about the root of a root. Root of a root. Now, in this case, we have a case like this. The mth root of the nth root of a. Sorry. So, the property says that whenever you have a root of a root, you simply say that it's the m times nth root of a. Now, what about some example? The fourth root of the cubic root of 16, it's the 12th root of 16, which is the 12th root of 2 to the power of 4, which remains the cubic root of 2. What about the square root of the cubic root of a? You can say that it's the 6th root of a. Alright? Now, of course, you have to mention that a should be, in this case, positive or equal to 0. So, this was all about the nth root of real numbers. Why don't you subscribe to my channel? You'll be notified whenever I upload new videos. I can also share with you my Instagram or Facebook account. You can contact me directly, or you can simply leave a comment below. I hope it was helpful, and see you next time.